Now, the next will be the understanding how the static keyword is used in Java mainly for the memory management, right? So there will be a times when you all will want to define a class member that will be used independently for any object of that class. Normally, a class member must be accessed only in conjunction with an object of its class. However, it's possible for to create a member that can be used by itself without reference to a specific instance. To create a such member that can be used by itself without reference to, okay, so we declare the with a keyword called as a static when the member, whether it is a member function or it is a data member, when it is declared with the prefix in the keyword called as a static, it can be accessed before any objects of its class are created. And without reference to any object, you can declare both the methods and the members to be a static. The most common example of static member is a main is declared in Java program static because it must be called before any objects or exist. So that is the advantage of the static keyword belongs to the class than instance of the class. And we may apply static keyword with any number of data members or the methods and the blocks and even for the nested classes also. Okay. Instance variable which are declared using the static because it must be called before any object is going to exist in its class is declared. No copy of the static variable is made. Instead, all instances of the class share the same static variable because it is available throughout the program since, right? So the methods declared static have several restrictions. There are some, suppose when we are going to declare the methods as a static, right? So prefixing the keyword called as a static. As we have discussed that there are inline functions which are prefixed by the inline keyword, and in C++ language there are some friend functions where we are going to, in Java also in future sections we are going to study the friend functions and friend classes, right? And when you are going to fix the either the keyword, right, static or friend or inline whatever it may be, they have their own rules and regulations, they have their own characteristics to represent a particular thing. Similarly, when you are going to declare the methods with the static keyword, they have the several some restrictions, some properties that we need to remember. They can only call other static methods. So static member functions or the methods, they can be called only using the other static members, not with the any other variables is used. Okay, only static member is called and it is used. Second is they must only access the static data. They are going to access only the static data. They are not allowed to access the other variable which are non-static. Okay, they cannot refer this or super in any way. The keyword super relates to the inheritance. Okay, we will discuss that super keyword in when you are going to come across the inheritance chapter. Okay, now this as I told, the variables are also known as class variable, methods are also known as the class methods, and we can use those in the block or even in the nested class also. So static variables, the example program without static variable. In this example, we have created an instance variable named count, which is incremented in the constructor. Since instance variable gets the memory at the time of the object creation, each object will have the copy of the instance variable because separate memory location is allocated for each and every data member of a class. In that way, okay, each object will have the copy of the instance variable. If it is incremented, it won't reflect to other objects. So each object will have the value 1 in the count variable itself. Any number of times you are going to execute, all the time the count value will be 1 only. So it reinitializes the values. Okay, so when you are going to declare that as a count, right, count as a static variable, so it gives a previous execution value it will not get erased, right? It keep on incrementing to the existing value. So that is the difference between the creating the static variable, declaring the instance variable as a static, and the normal static variable. Say you take this example, class counter. Okay, so now int count is equal to 0. We will get memory when when the object is created. So we have taken the counter as a constructor to initialize the values, right? Count is incremented by 1. So as soon as it is going to increment by 1, that is going to print the value of the count. Okay, next is class my program, beginning program, public static void main string args, counter c1 is equal to new counter. So c1 is an object which is created under the new operator counter, right? So now this counter c1 is an object which is created under the counter. Okay, counter c2 is equal to new counter, counter c3 is equal to new counter. Okay, now closing of the we have created three objects, c1, c2 and c3. So new counter, and the new as we know that it is going to allocate the memory space dynamically, right? Output will be one only. Any number of times you create object, the output will be one only, because whenever each object is created, the count value initializes to 0, and when it executes automatically, count is incremented by 1, and it is going to print the value of the count is equal to 1 for any number of objects which you are going to create, because it is not a static value which is going to stores the previous execution value, right? It is an instance variable. When you are going to come out of that particular constructor function, again that variable dies off, right? Die off, then it is going to reinitialize the value is equal to 0. Now you take the you take the example program with a static variable. When what happens when we are going to create the count as a static variable? Okay, as we have mentioned above, static variable will get the memory only once. If any object changes the value of the static variable, it will retain its value. Okay, if any object changes the value of the static variable, it will retain its value. Class counter static int count is equal to 0 will get the memory only once and retain its value. But means the previous execution value is going to be stored as it is in the count. Okay. Now see, same program, counter, it is a counter is a constructor where we are going to increment the counter in the constructor function. As soon as we are going to increment the counter, it is we are printing the value of the count. Okay, so system dot out dot println. Now my class, my program, public static void main string args, counter c1 new counter, object c1 is created, and automatically the counter constructor function is going to be executed. Next, counter c2 new counter, that is the c2 counter 2 is going to get executed. Counter c3 new counter, right? And the c3 object is going to get executed. Okay, now what happens whenever we are going to create these three objects? As I told that static is something like a global variable. It is having the meaning in throughout the programming file. Okay, and once the memory is created, it retains that value. The value of that location will not die off even it comes out of the function also. That is because of the reason it is a static variable. Okay, we are going to declare that as a static variable. Okay, so now what happens is when we are going to create three objects, it keeps the value, that is a c1 c2 c3, it keeps the value. Okay, and it is when c1 is created, counter is incremented by 1. When c2 is created, again the same constructor function is executed. It keeps the previous value, count is equal to 1. 1 plus 1 will be 2, And again when the C3 is created, again your count is incremented by 1, it becomes a 3. See the difference here. If you don't declare this variable as a static, as a normal instance variable, this count value will die off after exiting from that particular constructor. Whereas when you are going to declare the count as a static, okay, and this memory only once created only once, and it is going to return its value. So here see 1 1 is the answer, because every time it gets initiated to 0, and count is incremented by 1, and it will take the value 1 itself when how many number of objects you are going to create also, right? Here, whereas in case of the static variables, here since you are declaring that as a count as a static, okay, your value is going to be incremented by 1 1 2 3. Okay, so this is about the static variable, that is the data member. When you are going to declare it as a static, how it is going to retain its value when you are whenever the object is created. Okay, so now the come to the methods. So that is a methods or nothing but the member functions. In Java we call it as a static method, right? So some static methods, right? When you are going to declare static, that gets the block gets executed once when the class is first loaded. Okay, then as I told, it uses only static variables. Okay, and all the instances of the class share the same static variable, right? And all the static methods are prefixed by the keyword called as the static. Okay, they are going to prefix the keyword called as a static. Now the static method, see, if you apply static keyword with any method, it is known as a static method. A static method belongs to the class rather than object of a class. A static method can be invoked without the need for creating an instance of a class. Okay. A static method can access static data members and can change the value of it. Okay. Static method can be invoked without the need for creating an instance of a class. Static method can access the static data members and can change the value of it. Okay. We'll take a simple example which is going to illustrate a cube of a given number by static method. Okay. So class calculate, the name of the class we are given is a calculate, and file name is also will be the same. Static int cube int x. Okay. So see, we are declaring the cube as a static method. Remember, there we are prefixing the keyword called as a static. So we are giving the return x into x into x. We are returning the cube of x. Okay. So class my program public static void main string arguments, right? So we are going to call a calculate dot cube of 5. We are sending the parameter 5 to the static member function or a static method, and it is going to take x is going to take the value as equal to 5, and it multiplies 3 times, which is going to be the cube. Okay, then you see here it is going to print the value as a 125. So here remember that this is a method for a static. Okay, so we'll study about the next word is this keyword. Okay, this is the word keyword which you are going to represent. Sometimes a method will need to refer to the object that is invoked, right? So to allow these, Java defines the keyword called as this. This can be used inside any method to refer to the current object. Okay, that is, say for example, this a is equal to 10. Okay, implicitly we are saying that this a particular variable will be is equal to a. Similarly, to when we are going to use this keyword when we with respect to the object, right? This is always a reference to the objects which the method was invoked. You can use this anywhere. A reference to an object of the current class type is permitted. To better understand what this refers to, consider the following version is that, okay, so this keyword is can use to refer to current class instance variable. You may be referring to the objects, or you may be referring to the data members, that is refer to the current value, current variable. Okay, if if there is ambiguity between the instance variable and the parameter, this keyword resolves the problem of ambiguity. Okay, so that is a very important advantage of this keyword. Okay, because when you have difficult situations where we want to take a particular instance variable and a parameter, okay, so compiler will be in a dilemma which one it has to take. Okay, so that problem will be solved by the this keyword. Okay, this keyword is going to um, this keyword is going to resolve the problem of ambiguity. Let us understand the problem if we don't use a keyword by the example given below. Class student int id string name, student int id comma string name. Okay, so I am taking a simple example which is going to given the that is about the keyword, this keyword, right? And int id string name, student int id comma string name, id is equal to id. So whatever the data we are sending from the main program, that will be copied into the id. In turn, that id will be assigned to id. Name is equal to name. So name, string name, which is going to assign to the name. Void display system.out.println id plus name. So we are printing the id whatever we are sending from the main method to the constructor. In turn, we are printing that value using the display function. Now class my program, okay, static void start public static void main string arguments. Student s1 is equal to new student id comma name of a student, and we are creating another object s2 is equal to new student 321 comma rn. So these are the two ids, and with the student to student name. S1 dot display, S2 dot display. When we are going to create a S1, okay, that corresponding values will be assigned in the constructor function. And when we are going to create a S2, so the corresponding values will be assigned to the corresponding values will be assigned to the S2 values. So see here, so what happens here? So we are not using this keyword, right? So even though it assigns, okay. So since we are not in the above example, what happens? Formal argument instance variables are same. That is why we are using this keyword to distinguish between the local variable and the instance variable. That is the reason why it is going to assign the null. See the parameters what you specified inside the parenthesis id name. So same, okay, same name we are used in the formal param arguments, right? Both will be the same. So what happens when that is a case? So we it will not identify that it will not differentiate, and it will not assign the values, since both will be the same. So at that time we will get the value is equal to null cap. It is a 0 0 for id and null for a string. Okay, so to avoid such conflicts that arises when we are going to use the variable instance variable name and the formal parameter name is the same. Okay, so this keyword is going to be useful. Okay, now and there are some situations where we don't want to declare, we don't want to use a different name for representation of the this what for representation of the name. Okay, so I want to give the name itself, I don't want to use some other keyword to tell it is a name. Okay, I want to give the same name, I want to use the same variable name. Okay, that situation we are going to use this this keyword. Okay, now see here example, this keyword class student int id, right, string name int id comma string name, this dot id is equal to this id. What happens here, see this keyword is used implicitly, it assigns the values of id and name to the respective the instance variables. Okay, when you are trying to print that value, it is going to print the value id and the name. This one student. Okay, 111 Anu 222 RN. See now in the previous example we got 000 and null, and here we got the ID correct and the name is also whatever the parameters you are sending. This is because we have used this keyword internally to assign the instance variable with the same name. So that conflicts are going to be resolved with the use of the this keyword. That is the advantage of this keyword. Okay, now come to the, as I told, that nesting of classes, nesting of for, nesting of if, nesting of switch. It all means that calling one more inside the another is called as a nesting. Whether you are giving, you going to use a nesting for if, it is a nested if you are going to use a nested if else, then it is nested if else, like that.